DevOps on the C# compiler team with Jared Parsons.
The Azure DevOps Podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Hello, welcome to the show. I'm Jeffrey Palermo, your humble host. Make sure to check out www.azuredevops.show for past episodes and show notes. A few announcements. My latest book, .NET DevOps for Azure, is available, and you can get it at bit.ly/.NET DevOps book. If you are going to attend virtually the .NET Conf on September 23rd through 25th, look for me one of those days when the schedule is released. I'll be presenting .NET DevOps for Azure and demonstrating all about that at the event. And so look up .NET Conf, and you can go to bit.ly/.NET DevOps book for community. If you're running a user group or a conference and you want a couple physical giveaway copies, be happy to send those to you to support the event. That's bit.ly/.NET DevOps book for community. And also Microsoft Ignite is coming up, and it's on November, the first week of November, and I'll be at Microsoft Ignite. And I'm sure I'll be doing a little podcasting from there. But also, I am one of the official conference community reporters. So I'll be walking around with a camera crew and interviewing speakers and reporting from the conference. So keep tabs on my social media channels for all kinds of reporting. You can go to youtube.com/Jeffrey Palermo, Twitter/Jeffrey Palermo, and keep tabs for information leading up to Ignite and also during the week. So let's get into the show. I'm really excited to speak today with Jared Parsons. He's the principal developer lead on the C# compiler team. So every single one of you out there uses his code on a day-to-day basis. Jared, how are you, sir?
Hey, I'm doing great. Thanks for having me on the show.
Yeah, I really appreciate the time. And you guys do phenomenally complex and important work. And this is a DevOps podcast. And we're all about world-class software and how to move faster, how to increase quality. And every single person listening to the show uses Visual Studio on a daily basis. But you guys are a software team. And so you have a DevOps environment. You have a process. And so I'm really excited to be able to learn what that is and have you share with the listeners. So thanks for being with us.
That's awesome. My outside compilers, like my biggest passion is infrastructure and DevOps. So really excited to talk about all the work we put into the compiler here.
Absolutely. So before we kind of get into the details, how long have you been on that team? What's been your progression there at Microsoft in your career? How'd you land there?
So I started at Microsoft about 15 years ago, and I transitioned over to kind of the languages and compiler teams about my second year. And I've since then, so for about the last 13 years, I've worked on languages in some form or fashion. I started on the compiler team, then I kind of worked on our debugger layer for a little while, then on the IDE team, and spent a little bit of time in research. But I've been back on the core Roslyn team for about 5 years now.
Okay. So you know every bit of that code base, I imagine.
I've definitely added bugs to every layer throughout my career.
Awesome. Well, if you wouldn't mind, if we could just pick apart what the DevOps environment looks like for the C# compiler, and let's just start at the beginning. How is the source code organized?
Well, so the source code, when we talk about it, we have the GitHub repo. It's the .NET Roslyn repo. And it's not just a compiler. We actually have a repository for the entire C# experience. And so this includes the code all the way from the batch compilation process, all the way through IntelliSense, debugging, syntax highlighting, edit, and continue. It's all in one place. And together, it ends up comprising of about 5 million lines of code.
Okay. So is all of that public on GitHub, or are there pieces that are private internal?
That's all public on GitHub. It's all in the .NET Roslyn repository.
Okay, so is that the github.com/.net account?
Yes.
Okay, I just want to make sure we get the right one because there's so many of them out there. So .NET/Roslyn, right?
Correct.
Okay. Now, if someone clones that repository, will they be able to actually build it locally?
I sure hope so. We put a lot of work into that. The goal we have for our repository is to make it as friction-free as possible. And the idea is that like we actually bootstrap all of our tools. And so on a clean Windows machine, you should be able to clone the repository, hit build, and get the entire product built on your machine. And we actually use DevOps to ensure that we can meet that guarantee. We have a fraction of the build legs that we use on our job run on a clean Windows machine. So we verify on every change that we can build our source code and run all of our tests on just a standard Windows machine with nothing installed. Nice.
Okay. All right, listeners, go out and try that. That'd be fantastic. You know, I don't know about you guys, but when I was going through my college courses about computers, there was talk about compilers, but we never actually dug into a real world, widely available compiler. So now that, I mean, this is insane that the actual compiler and all of the code is there. Now anybody can just essentially study canonical works of art in the industry. It's amazing.
Yes, it is nice. It's something I definitely would have appreciated back in my university days.
Mm-hmm. Okay, so you have, and that's a single Git repository for the whole compiler, and you said the experience. So besides the compiler, what other components are included?
So we essentially, you have the compiler, you have all of the Visual Studio code. So basically the Visual Studio experience, which is specific to C#. So all of the syntax highlighting, all of the IntelliSense, all the kind of the experience you get in the locals and watch windows when you debug, all of those components are within that repository. And a number of those components actually end up getting shared in other development environments. For instance, the C# experience you get for VS Code and Visual Studio for Mac, the C# components, they come out of that repository and are part of our standard build process.
Okay. And so you said, I think you use Azure DevOps Services?
Yes, we are one of kind of the early converts to Azure DevOps when they kind of made the push to make it a great service for GitHub repositories. Mm-hmm. And so we spent a good portion of last summer kind of working with the Azure DevOps team and all of the scaling requirements we have due to kind of the size of our repository, the number of jobs we run, and the number of tests we run to make sure that they could provide a good experience for users who meet kind of our level of needs. Okay.
And do you have any a branching model that y'all have adopted?
So we do have a branching model. So we kind of, so there's two different layers of branching. We have to ship in Visual Studio. Visual Studio is kind of our primary delivery vehicle. And Visual Studio is now on a fairly rapid update model, where today you are probably using 2019 Update 2 on your computer, but we're very close to releasing 2019 Update 3. And so we generally have a branch for every active release of Visual Studio. As for actual language features, though, we put all of our big language features, which is pretty much all of them, into a separate branch. We essentially have kind of a pseudo directory structure in GitHub. So every feature ends up under a branch called features/. And we branch for all of our features. It's typically a long-lived branch that we've had branches live for as short as a month and as long as 4 years.
Oh, wow. Okay. And are all of those branches built upon Git push or only master?
They are all built in during pull request. So we don't necessarily, on the feature branches, we don't necessarily have a rolling build for pushes because it's generally a small number of developers. There's a very low chance that you're going to have two developers make a change at the same time that conflicts post-merge. So we don't run all of those on continuous integration, but we do at minimum run it on all pull requests.
Okay. So your continuous integration build, the configuration in Azure DevOps Services, is it Is it YAML-based or is it the step-based?
It's definitely YAML-based. We found that was actually one of our big requirements to move to Azure DevOps is to have a YAML-based experience. And the reason why is we have so many branches and all of our branches have different requirements, often requirements that you can't express in other branches. And having a single kind of UI-based model for that just doesn't work. We needed to have our DevOps configuration flow with the code that was essentially exercising it. And
awesome.
To give you like a concrete example, we did a lot of work to implement default interface methods. And default interface methods is something that required, it's a C# 8 feature. It required runtime work on both the core CLR and Mono teams. And when we were doing that work, we had to do a lot of work with Mono for them to get their implementation up and running, get it shipped over to another branch. And we were essentially using DevOps to control where the default interface test ran. So we had a whole Mono leg for this running, but we only had it running in the feature branch where we were like kind of working out all the kinks with Mono. If that in a UI model, it would have started running on all of our active branches and it just wouldn't have passed.
Got it. Man, that's for listeners who haven't even used the YAML functionality, that helps out with branching so much because otherwise you start with essentially a global script for your build. And if any of the branches need something different, you can't change the global script because then the build breaks for the other branches that don't. So I'm going to go and check out the Roslyn repository just to see what your YAML configuration looks like. That's great. Okay, so what kinds of goodness do you pack into that CI build, and how long does it run for?
So the goal for our CI build is to have it done in under an hour. And it occasionally jumps up and down, but the metric that we go for is to have the longest job that we run should take less than an hour. So in terms of what all do we do in CI, so we do quite a bit. So kind of the first step we do on most of our legs is we actually build the compiler.
And when you say legs, do you mean build agents?
Jobs. So we actually, when you kind of run a PR against Roslyn in Azure DevOps, I think we run about 12 different jobs. So for instance, we'll run kind of like unit test on Windows 32 is one job, Windows 64 is another job.
Okay.
All of them run in parallel.
Okay, got it. So that's within your YAML configuration, you have 12 parallel parts of that build.
Right.
Okay. All right. What's next?
Okay. So the first one we do is the first step on many of those jobs is build the compiler. Just go in, build the functioning compiler, put it aside, and then build the entire code base using that compiler. So validating that not every single change to the C# compiler, we can still build the C# compiler.
It's important.
It's important, and you would be surprised how that was actually somewhat of a problem for us in the initial, when we kind of first started doing the Roslyn project. We would basically, instead of building on every change, about every month or so, we would say, take the latest compiler and use as a tool set for the actual compiler code base. And what we found is, in that month period, we managed to break our ability to build the compiler. And searching through a month's worth of changes to figure out what you broke was hard. And so we kind of fixed that problem forevermore by just saying, we will ensure we can self-host the compiler on every change that we do.
All right. What else you got packed in there?
So after that, a lot of it's pretty standard. We have a lot of standard legs, which just build the code and run the unit test. So for our unit test, we have roughly 80,000 tests in the repository. And that's for compiler all the way through Visual Studio IDE and all debugging in ENC. And we run those tests on a number of different configurations. So we essentially have Windows, debug release, 3264. We have Windows Core CLR. We run against the Mono runtime. We run against .NET Core on Linux and Mac. And all told, when you kind of fan all the tests out on all the different configurations we run, we end up running about 750,000 tests on every PR.
Okay. And that makes sense because you have multi-platform targeting. So essentially, you have an hour-long build time, but you're actually running It's 12 builds or 11 builds?
Around 12. It goes up and down based on some work we're doing, but it's around 12.
Okay. So 60 divided by 12, 5? So that's 5. A 5-minute build for each one.
About 5.
Hey, that's...
Oh, no. So not a 5-minute build. So each job,
they're all parallel.
They're all in parallel. So we want the longest one to be about it. Our tolerance level is about an hour is when we start debugging what's going wrong and how can we improve that.
Okay. Are there any platforms that say this whole process is more speedy than others?
Generally, our Linux and Mac legs are the fastest, and that's because because like Visual Studio doesn't work on Linux. And so there's a whole section, like we don't run any of our Visual Studio tests on Linux or Mac. That's pretty typically just kind of the compiler layer that we're running tests on.
Okay.
The Azure DevOps Podcast is sponsored by ClearMeasure, a software engineering firm and Microsoft Gold partner, empowering development teams to be their best. ClearMeasure equips developers with the DevOps tools, methods, and automation necessary to focus on building their applications, rather than wrestling with builds, deployments, or environments. Click clear-measure.com to see whether a DevOps implementation is for you.
Okay, so the compile and runs the unit tests, and then getting ready for packaging and releasing. How do you have it configured next? How are you triggering, and what is the next step?
Oh, so we're not done with CI.
Oh, okay. Sorry about that.
We actually no.
Well, let's keep going.
Yeah, we actually have a number of other legs. Like we have a leg where one of the features of the compiler is that it's fully deterministic. So if the compiler gets the same set of inputs, it will produce byte for byte the same set of outputs. And so we have an entire leg in our CI system where we build the entire Roslyn code base 3 times, and once on a different directory path, and verify that in all 3 builds we get byte for byte the exact same output.
I'm guessing that's bit you in the past?
Yes. Well, actually, it was kind of a learning lesson for us. This feature is called determinism, and we implemented it with our initial Roslyn release. And we had a whole bunch of unit tests for determinism, and they all passed. And we said, yay, the compiler's deterministic. And then we tried to compile the compiler and found out that actually it's not deterministic. And as we shook out all the bugs, we kind of realized that unit testing only took you so far for that feature. You really had to have some rigorous end-to-end testing to make sure that the entire code base was functioning together. And so we wrote that leg to kind of, for once and for all, prove that we and all of the tooling that we use in our build were fully deterministic. We also have another leg, which is our build correctness leg. And what that does is essentially we run our standard compiler process with a bunch of extra analysis, both during the compilation and examining all of the build outputs after they're finished to make sure that we just have a very clean build environment. So, for instance, making sure that we don't have any race conditions in our build that would result in double writes, and that we meet we have a bunch of like analyzers around how threading works, around how certain features work in the compiler, and certain domain-specific checks for the compiler code base that we run on this kind of build correctness phase.
Okay. Have we covered all the legs, or you still have?
I think that's the big items there.
That's a lot going on. You know, when you compare it to more simple software, say an ASP.NET website, the build does unit tests, and if it calls out to a database, some integration tests, but then it has to be deployed to Azure or IIS server to do full system testing, whereas that full system end-to-end testing, you're actually incorporating some of that into your first line build process that compile the compiler.
Exactly. And that's because we've just found that it's more efficient to do that for us, because the cost of making those mistakes is so high that it becomes much cheaper to just find it earlier. We added that when we first did that bootstrapping step, people kind of questioned, like, is this worth it? We're going to pay like an extra about 2 minutes per build. Is this going to pay off for us? And it was just simple math. It's like when we mess this up, it takes days for us to figure this out. And based on the number of times that we catch ourselves with this leg, we actually messed that up about 10 times a year. So
Wow.
it's a very efficient cost trade-off for us.
Once a month, 5 days, that's 25% of the year that could be lost.
Yeah, a good chunk.
All right, so we're done with the build at this point. Yeah. Okay. All right. So what in your configuration, what happens next?
So the next thing we do is on essentially once a day, we take kind of the output of whatever our release branch is and we insert it into Visual Studio. And that's both we're inserting the products that we're giving to customers, so like the C# compiler, all the whatever we've changed in the IDE experience. But the other thing we do is we actually insert the compiler as the tool set for the Visual Studio build. So in the same way that we ensure that the compiler can compile itself every day, we ensure, can we compile Visual Studio every day?
Okay. So that's a secondary build.
Yeah, it's a secondary kind of like
a chain build.
Yeah. It's not exactly chain. It's not a part of our PR process. It's kind of like a rolling thing we do once a day.
Okay. Somebody hits a button. Or is it a schedule?
It's a schedule. So it's completely automated, except when we mess it up and have to figure out what we did wrong.
So when you say insert it, does that mean the CI build finishes? What is the form of, at that point, what is the form of your release candidate? Is it a directory of files? Is it NuGet packages? How do you package that up and where do you put it?
We actually have to do a separate build before we insert into Visual Studio. So all the builds we do in the public, there are no secrets. Everything is publicly available. You can send a PR and build whatever you want on a repository. For official builds that ship to customer machines, we have to take some extra steps. Like we have to certificate sign all of the binaries. We have to strong name those. And we don't do that as a part of our GitHub experience because it would allow people to get whatever binary they want signed by Microsoft. So we essentially use merging as a gate to that process. And once we've merged and we're pushed into a release branch, then we have a secondary pipeline that kicks off, does an official build, and that produces roughly the same output as a PR build, but with all the binary certificates signed, fully strong name signed, and ready for insertion into customer machines in Visual Studio.
And do you use Azure Artifacts to store the result of that build?
Absolutely. Yeah, we use Azure Artifacts to push everything. At the end of every build, we push up all of the binaries ready for release. And when we insert into Visual Studio, we have a release pipeline, which essentially goes off, finds our last successful official build, grabs the artifacts, and then inserts them into the Visual Studio codebase.
Okay. What format of artifacts have you chosen? Is it a NuGet package, a zip file, a directory of open files?
It's, for the most part, we have a number of NuGet packages that we produce. All of our binaries are APIs, and so we produce NuGet packages. We also produce V6 files. For anyone who's ever written a Visual Studio extension, they'd be very familiar with what a V6 is. We also have a couple of proprietary formats called SWIX or SWIX. That is specific to the Visual Studio setup technology, but it is very similar to a V6 file. It's a zip file with a manifest. We also have some symbol packages. So if you've ever worked with symbol servers, like you're debugging Microsoft code and it downloads the PDB for that, we have some artifacts that we emit that we can then later push up to our symbol servers.
Mm-hmm. Okay. So at this point, is there anything else between, or are those the signed ones? Are those the artifacts that actually ship? Or are there any further steps in your pipeline beyond that?
There is one other step in the pipeline. We actually have an optimization phase in our pipeline. So if any of your listeners are familiar with like profile guided optimization or POGO, we do have a series of tests that we kick off when a build is finished. And this is asynchronous. Essentially, we have a release pipeline where we say, hey, we publish some artifacts, go run them through the training scenarios. And what that does is there's a number of scenarios we run in Visual Studio, like open a C# project, build it, close Visual Studio. And we essentially profile all of that. That produces some IBC data. And then we have tooling, which then kind of modifies our binaries to basically mark certain methods for engine, kind of move around the binaries, and just essentially make them faster for execution.
Okay.
And that is kicked off kind of during our official builds when we kind of have the signed binaries, everything's available. That triggers a release pipeline to say, hey, time to go train, kick that off. And later on, that will get published out to a place that we can then consume during our normal build process.
Okay, got it. And is that essentially the end of the pipeline?
That's the end of kind of our release pipeline to Visual Studio. So at the end of, once we insert into Visual Studio, that kicks off an entire pipeline within the Visual Studio source tree where they basically take our binaries, insert them, they run a number of verification tests, they run a number of performance tests, and just and ensuring the health of the Visual Studio product. And after that, once that is merged, that is how customers get the Visual Studio binaries. Like that is, it's merged, it's in a release train, and it will come down within one of the updates.
Okay.
But we also then, in terms of tool setting, compatibility is something we take very seriously in the compiler team. It's our number one feature. And the best way we found to enforce compatibility is make sure as many people as possible are using our latest compiler. And so in the same way that we push compilers off to Visual Studio, we actually have a way that we can push the newest Roslyn compiler through the entire .NET SDK family of products. So within about every couple weeks or a month, we then kind of update the compiler that we all use, for instance, that is used to build the CLR, that's built to use the core effects repository, ASP.NET. We essentially push that down to them a couple times a month.
Okay. Backing up for just a minute, there's a lot of people that are using static code analysis, both Roslyn analyzers, the built-in ones, and then other products. Do you have that in place in your pipeline?
Yes, we are heavy users of Roslyn analyzers, and we use them for a number of different things. So we actually have an entire repository called Roslyn-analyzers, and that is a collection of both publicly, like analyzers meant for general consumption, like the Microsoft .NET Core Analyzer package is built out of there. But it also contains all the analyzer that we use for our own build processes. And some of the types of static analysis we do is, for instance, ensuring configure await is used on every await call in our code base. We have a very aggressive threading model in both the compiler and IDE layers. And we use those analyzers to ensure that we don't have any hidden switches to the IDE. And we essentially use that analyzer to force that every switch to the main thread of the code base is annotated with a configure await true. So it's very visible when we're reading the code. We also have analyzers where we're enforcing certain style conventions within our code base. And that's all based off of editor config. And that's something we shipped in Visual Studio a couple of releases ago, but we've been kind of dog fooding it within our repository. Mm-hmm. And we also consume analyzers from other people. So there's a Visual Studio SDK produces an analyzer for kind of threading best practices within Visual Studio. All of the kind of lessons they've learned over the years on how not to program Visual Studio, we consume that as part of their package and actively run it on all the parts of our code that exist in Visual Studio. We also run the XUnit analyzer package, which is fantastic.
Okay, so your tests are XUnit tests, I'm gathering.
Yes, they're all XUnit. And their analyzers have shown us some very embarrassing things that we've done in our code bases over the years. The first time we kind of took down the XUnit analyzers and ran them, it reported a couple thousand violations in our code where it says, oh, you're saying assert not null on a struct. And we're like, new XUnit analyzer. Yeah. They've got to have a bug. There's no way we did that. And then we looked at the code and we're like, oh my God, at one point in time, that used to be a class. We switched it to a struct, and now our test is doing nothing. And that was very educational for us.
You're right. If you just do a simple refactoring, the compiler's happy again, but you had no other way to know that there was logic based on class versus struct.
Exactly. And so it was both a very fulfilling lesson for us to learn. And it's like, oh, we produce this thing called analyzers and it has value, but it's also depressing that, oh my God, we did that thing. And we need to fix that.
Yeah. It kind of confirms that we're all human.
Exactly.
Okay. So if people go into the Roslyn repository, they'll be able to see your build and even see the exact list of analyzers that you're using.
Yes.
Right?
Yep.
Perfect. Yeah. That's one of the that's one of those levels of that I don't see people talking about enough, is the rule sets of analyzers that are configured for a particular piece of software, and just how many problems it finds. And even with the proliferation of JavaScript code bases for SPI applications, there's a lot of people that don't really know that if you want the triple equal sign is like the most restrictive, and there's weird anomalies if you use double equal in an if statement. And I didn't know that for the first 10 years of my career. So
yeah, and it's been we've also are pretty aggressive. Like when we find problems like that in our code, we're actually pretty aggressive about like, could we write an analyzer rule so that we never hit that problem again?
Mm-hmm. Right. And so for toolset, you're on Visual Studio. Refactoring tools, just out of curiosity, do y'all use any third-party Visual Studio add-ins at all, just for your own coding?
No, we use Visual Studio out of the box for all of our coding. And we basically are, because the IDE team, for instance, is very invested in refactoring. And so we heavily dog food all of the features that they're adding. And basically they add a new feature. It's like, let's try it out in our code base. Let's see what breaks. In particular, because our code base is so large, we can often root out performance or kind of corner case issues by just using our own tooling.
Nice. Okay. And this, you target so many different platforms. At the Build Conference, they were talking about the new Visual Studio Online with Visual Studio Code actually running from a URL in the browser. So is that baked into your pipeline? How are you actually targeting something that's going to run from a URL?
So that is essentially a software as a service piece. And so what we focus on is essentially keeping our code portable. Like if you look at how Visual Studio Analysis runs, most of and actually if you kind of back up a little bit and go back to like Visual Studio 2015, at that point in time, virtually all of the experience you got in Visual Studio for C# was running in the Visual Studio process. And that includes like all the searching we did to make find all refs fast, IntelliSense, that was all there. And that is a very limiting thing for us. One, because Visual Studio is 32-bit and we're all kind of competing for the same memory. And also because it turns out that all the background operations you're doing in Visual Studio end up kind of impacting some of the like clean typing experiences because you're using the same heap as the code that's generating IntelliSense. And since then, we've been kind of on a mission to get as much of the analysis we can out of process. And so that we can do all of this really cool analysis outside of Visual Studio. It doesn't impact your typing experience. We can churn the GC all we want, and the keystrokes will still go through very smoothly. And so for software as a service, this is something that we've been kind of in some ways setting up for a number of releases, because our analysis engine is already largely running out of process. And for us, a new URL is just saying this is just a different way of hosting that same service.
Okay, that makes sense. So the code is going to go over to your servers, compile, and then the DLLs come back?
Yep. For the most part, with the IDE, they don't end up building. They are more asking all the questions up until build. Like, what are the diagnostics? Give me IntelliSense. What are the members, locals? Yeah.
Awesome. Well, man, this is just a fascinating conversation, and the C# compiler being such a depended on and complex and widespread piece of software. GitHub.com/.net/Roslyn is where the code base is. Jared, I really appreciate the time you spent with me. If our listeners want to learn more on top of grabbing the code, is there any other resources that you would point them to?
I'd say mostly There's if for people who are more interested in kind of the language design aspect of the compiler, we also have .NET/C# Lang, and that's where kind of all of the language designers sit. That's where we kind of publish all the features that we're looking at in the language design team, all of our specs. That's another great place to go and get some information.
Okay, that's github.com/.NET/C# Lang, all spelled out.
Yes.
Perfect. Awesome. Well, thanks so much, Jared, for spending this time with me. I appreciate it.
You're welcome. Thanks for having me.
And until next time, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.